The first kind of problem in section 2.4 is involved with Venn diagrams that have three intersecting sets. And our job is to get used to some of the notation and start to be able to picture some of these things. So I'm going to go through and just describe some of these for you. So if you're asked for the elements in set A, that would be 1, 2, 3, 4. Those are the numbers that are in A. If you're asked for the numbers in B, it would be 2, 3, 5, 6. If you're asked for the numbers in set C, it would be 3, 4, 6, 7. If you're asked for the things that are in A and B, A intersect B, you look at the circle A and the circle B, and the 2 and the 3 are in both, and so this would be the set containing 2 and 3. What about A intersect C? Do you see what it's going to be? It's going to be the numbers 3 and 4, because this is where A and C overlap. These are the numbers that are in both. B intersect C, it's the intersection of the circle B and C. That's the numbers 3 and 6. What about A intersect B intersect C? That's the numbers that are in all three circles, and that's just this central part 3. What about the universe? What numbers are in the universe? Well, it's 1, 2, 3, 4, 5, 6, 7, 8. 8's outside the circles, but still in the universe of the problem. What about A union B? Everything in A and B together. So we have 1, 2, 3, 4, 5, 6. B union C, we have 2, 3, 4, 5, 6, 7. It's everything inside these circles together. A union C, 1, 2, 3, 4, 6, 7. Everything in A and C all put together. A union B union C, it's everything that's in any of these circles, so it's 1 through 7. The only one missing is 8. The subtraction of two sets is everything in A. That's what you start with, all the stuff in A. And then you take away from that anything that happens to be in B. So we got 1, 2, 3, 4. That's all in A. But the 2 and 3 are in B. So this is just 1 and 4. That's all that's in the set A subtract B. Now what is the complement of A subtract B? If A subtract B is 1 and 4, then the complement of 1 and 4 is everything that's not 1 and 4. So it's 2, 3, 5, 6, 7, 8. That one I felt like I better list. It's everything in the universe that's not 1 and 4. A union C, take the complement. A union C are all these numbers inside here. The complement is everything that's outside these two circles. Well, that's just 5 and 8. So the answer here would be 5 and 8. Here we take B union C. That's everything that's in these two circles. That's 2, 3, 4, 5, 6, 7, and we intersect it with A. So what is both in these two circles somewhere and in A? It's 2, 3, 4. So it's just 2, 3, 4. The second really important idea in section 2.4 is to use Venn diagrams to get a handle on compound statements like this one and this one, to see what they mean, and in this case to see if they mean the same exact thing. So I put a whole bunch of empty things, empty Venn diagrams up here so that we could work. So we have the intersection of two things, A and B union C. So I'm going to not erase my work. I'm going to take, and this is A, and this is B union C. It's everything in B combined with everything in C. And now I want the intersection of these two things. I want where they overlap. Well, we've seen this before. This is these pieces here. These pieces here are inside of A but they're also inside of B or C. And it's all the things that do both of those. So now let's go over here and let's start working on these pieces and see what happens. So what's A intersect B? Well, A intersect B looks like this. It's where the A and B circles overlap. And A intersect C looks like this. And now we want the union of those two. We want them put together. And so everything that's in this first intersection, in addition, combined with everything that's in this second one, and anything that overlaps, like this stuff in the middle, this intersection of all three, overlap just counts once. So we got all these guys, and we got all these guys, and lo and behold, these two are the same. Notice giving yourself plenty of space, and I gave myself even too much. I got carried away with copying and pasting. Giving yourself plenty of space to work is a good way of handling these kind of complex compound statements. What you don't want to do is just merely guess.